Okay, so in prior lessons, we solved systems by graphing. We've solved them by substitution, where we substitute one variable in terms of another variable. In this section, we are going to solve these systems by elimination. We are actually going to set up our equations so that we eliminate one of the variables, solve for the first, and then solve for the second. So we're going to start off quite simply. So we've got two equations, 6x minus 3y equals 3. You're going to notice too that the simple ones are not the ones that are actually problems that you will see ever. They're always a lot more complicated than this. So in solving by elimination, what we look for is one of the variables that when we combine the two equations, we can actually get rid of one. So let me point out the positive 6x here and the negative 6x here. We know that when you combine a positive 6x with a negative 6x, our result is 0. So we're going to know that this x term is now gone. Now we're going to combine our y terms. So we've got negative 3y, a positive 5y. So we've got a positive 2y equals, and 3 plus 3 is 6. Dividing both sides by 2, and we see that y is equal to 3. Okay, so now we have solved for our y value. Now we have to go back and solve for our x value. We can use either equation. I'm going to go ahead. I will use the top equation. So 6x minus now 3 times y, which is 3, equals 3. So 6x minus 9 equals 3. I'm going to add the, oh my goodness. I added that in my head, and then I was actually doing that. Mistake, don't make that. 6x is equal to 12, dividing both sides by the 6, and x is equal to 2. Therefore, my solution, gosh, you can't even see that. My solution to this, therefore, my solution is x of 2, y of 3. I'm going to go ahead and put that point into my second equation just to make sure that it works. So I had negative 6x plus 5y equals 3. Negative 6 times 2 is my x, plus 5 times my y, which is 3, equals 3. This is negative 12 plus 15, and that does equal a positive 3. So that point does work. Okay, so this was a very simple way to do it because it was totally set up for us. But it's not always going to look that way, and so we're going to look at some of the other ways. Excuse me, my hands are really cold, and so they are not working really well. I do apologize. And I just gave myself a paper cut. I don't know if you can see that, but it is going to start bleeding. So if I'm bleeding my own blood, that will be really bad. Okay. So sometimes you have got to adjust one of the equations in order to be able to do this. So let's look at negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. So if I multiply this entire equation by 3, I can get this to be a negative 15. And so I'm going to do that. I'm going to multiply this by 3, and that's going to give me 21x minus 15y equals, times 7 is 21, is 2, 3, 51. Okay, I should have known that, but yeah, my brain is as cold as my fingers are. Now I'm going to bring back down that initial equation, 15y equals negative 32, and I will now combine these two equations. As you can see, once again, now I have this, okay, which is going to equal 0, so that's gone, okay. Remember, you know, notice I multiplied 3 times each item within that equation, okay. So 21x minus 2x, that's going to be 19x, equals, and 51 minus 32, I know what it's going to be, but I just want to make sure that my brain is not messing with me. So 19x equals 19, so x is equal to 1. And now I'm going to go back to the initial equation, negative 2x plus 15 y equals negative 32, negative 2x plus, and, negative, I was going to make that times the 1, okay, instead of the x, so there I'm making it a dot, plus 15y equals negative 32. So this is negative 2 plus 15y equals negative 32. I'm going to add 2 to both sides. This will give me 15y equals negative 30. And dividing both sides by 15. Now let me shift a little bit. And y is equal to negative 2. So my solution set, coming back up to my original equations, my solution, or we can put it down here, whichever is easy, solution is x of 1, y of negative 2. Okay, so having used this, I can't even hold the pens right now. Having used this equation, I'm going to go back up, and now I'm going to use this equation to check my work. So 7x, oh, you can't see me, 7x minus 5y equals 17. Using my solution point, so 7 times 1 minus 5 times negative 2 equals 17. So this is 7. And here I've got minus, and this is negative 10. So if I just go ahead and do that, I can see that 7 plus 10 does equal 17. And so my answer is correct. So this is more indicative of the type of problem you're going to have. There's one more possibility that you might see. And you know, certainly on a quiz or a test, you're always going to be faced with one of these, and this is where we have got to adjust both equations. So let's look at 15x plus 3y equals 9, and 10x plus 7y equals negative 4. Okay, so there's a couple of ways to go with this. Once you know that there's not just one thing that I can do. I can't make 10 go to 15. I can't make 7 go to 3. So both equations have to be multiplied. I am going to go ahead and I'm going to eliminate y. You could just as easily eliminate x. I could have eliminated x by multiplying both by 2, this by 2, and this maybe by negative 3. Here what I'm going to do is I'm going to multiply this one times 7 and this one times a negative 3. So let's just see how that works. So this one is going to be multiplied by 7, and this one is going to be multiplied by negative 3. Now, once again, this could have been negative 7, this could have been positive 3. There is no just one way to do this. So this becomes a very personal thing as far as how you want to adjust them. So, yeah, and I think I'm already like questioning my methods here, because 7 times 15, and now I'm at 105 x's, whatever. So 105x plus 21y equals 63. Yeah, my numbers are really big. Negative 3, this gives me negative 30x minus 21y equals 12. Okay, well, at least that worked out well. So I have created this situation here, okay, and that does zero out. Okay, and that gives me, when I combine them, 105 minus 30, so that gives me, what, 75 x's, and equaling 75. Well, I really shouldn't have worried, so that didn't matter much at all. So 75 divided by 75, once again, x is equal to 1. Now I go back to my original equation. I'll go to the top one here, and I'll say 15 times my x of 1 plus 3y equals 9. 15 plus 3y equals 9. Subtracting my 15 from both sides gives me 3y equals negative 6, dividing by 3, and y equals negative 2. And so my solution here is going to be x of 1 and y of negative 2. So I don't know if it would be helpful for me to just show you how the same combination works, changing it up. But what I would like you to do is to go ahead. You can't even see my solution there. Go ahead and maybe work this problem a couple of different ways. Go ahead and check it, just to get that feeling of what we are supposed to be achieving here. So hopefully that gives you a good basis. Again, this comes down to just practice. So, you know, the more you do it, the more comfortable you become with it. So, so that's it. And I hope it was understandable.